Hi everyone, in this video we are going to see the topic single phase full bridge voltage source inverter. The inverter converts the DC supply into the AC supply. The inverter is classified into two types, that is voltage source inverter and current source inverter. Voltage will be the source and current will be the source, so it is named as voltage source and current source. In voltage source inverter, it is subclassified into single phase and three phase. The single phase and three phase depends upon the output. When we are getting a single phase output, it is single phase fully bridge inverter. When we are getting a three phase output, it will be a three phase voltage source inverter. Because the input is DC, so the DC will be only one phase, it is positive and negative. Look into the diagram, that is input is positive, negative, that is V. DC voltage supply is we are giving to the thyristors, 4 number of thyristors. This is fully controlled, full bridge controlled device, so the thyristors will be controlled and also the diodes are used for a freewheeling purpose. The thyristor is connected as what T1, T3, T4 and T2. The load is connected in between the diodes and also the thyristors. When we are giving parallelly, we are looking into this waveforms and also the circuit. 4 number of diodes and 4 number of thyristors, it is used for a closed path of the circuit. When we are giving a positive supply, the positive supply will goes to the T1 anode. So the T1 anode the T1 will starts conducting by applying a gate pulse separately. So the T1 starts conducting, the circuit will closes like this, that is positive of the supply and T1, and it move on to the load positive, load negative, and it move on to the T2. The T2 is connected to the negative of the input supply. The negative of the input supply is connected to the T4 and also T2. The positive region will comes from the load, so the T2 will starts conducting, the circuit closes from load T2 and also the negative supply. The output voltage waveform, look into the waveform. The output voltage, when we are giving, the first blue color indicates the gate pulse IG1, IG2. We are giving the gate pulses for the thyristors T1 and T2. So the output voltage will be appears in the positive region where T1 and T2 will get conducts. When we are turning off this T1 and T2, again the gate pulse T3 and T4 will get applied, so that the voltage will be in the negative region. The red color graph indicates that positive, and it move on to the negative and it conducts in the negative side, and it move on to the positive. In red color waveform, it indicates the T1, T2, T3, T4, T1, T2. It keeps on going by giving the gate pulses IG1, G2, G2, G3 and G4. Parallelly, we are applying the gate pulse so that it will conduct. What is the purpose of diode here? The load will be R load, RL load or RLE load. Just indicates when we are applying the gate pulses to the thyristors T1 and T2, it starts conducting, the inductors will get charges. When we are turning off, there will be some milliseconds of time between the gate pulses T1, T2 and T3 and T4. In that meantime, the inductor will get discharges. When we are cut off the gate pulses for T1 and T2, the inductor will get discharges. If the discharges, the inductor behavior is, it changes the sign and it starts discharging. When it discharges, there will be some path to flows through there will be some path for that discharging current, so that when we are using the diodes, it will start discharging through this diode and it freewheels through that diode D1 and D3. The discharging path is load D1, D3 and again into the load. When the gate pulse arrives, that is T3 and T4 gate pulse arrives, again it starts conducting and the inductor changes the sign and it gets charges. This is the operation of single phase full bridge voltage source inverter. Thank you.